So with the Christie Matrix STEM, and now the Christie Matrix STEM WQ, we've employed this dual input architecture. One of the ways that we've shown that and the capabilities and things that you can do with that is with NVG training, night vision goggle training, and using that second input as a fourth color component. You have red, green, blue, and now you have infrared. And there are a number of other things that we've demonstrated and that you can utilize that second input for, dual eye point, for stereo. But I want to focus today on the aspect of increasing dynamic image quality with 120 Hertz and increased update rates. So instead of just taking a 60 Hertz input and cutting down the amount of active write time within a given frame period that you have and incurring that decrease in maximum light output, you can actually input a second 60 Hertz input into the projector and use the projector as a compositing device, outputting a net result of 120 Hertz. So double the information rate, double the temporal update and frequency rate. So in looking at these side by side, moving at a constant velocity rate for our demonstrations, we typically use about 15 degrees per second. And what people immediately notice is that in the case of the WQ display, which has higher sampling rate in the spatial frequency domain, but lower in the temporal frequency domain, you get more blurring, and your temporal impact and your increase on the WU projector with lower spatial frequency actually looks better in terms of clarity and dynamic image quality. As we move from the center channel over to the right channel, we can see that if we actually have higher spatial frequency and temporal frequency, we get the best image quality. We also take advantage of the other aspects and features and improved performance that we have with the WQ projector, higher contrast and higher brightness. In some cases, it turns out that it's the classic innovator's dilemma challenge, and that is that you don't just want to increase the number of pixels. So we've seen increases from W to WQ all the way up to 4K, and we have projectors that project 4K for cinema applications, for business applications. We could use them for visualization and for simulation as well, but that may only be part of the solution. So sometimes we have to step laterally off that line of innovation that we would see. We're just increasing the number of pixels and change another dimension. And that dimension we think is the dimension of time, of update rate, and looking at how to maximize and combine both of those to give you the best dynamic image quality.